Our objectives for today's lesson are to be able to convert between units using the factor label method. The factor label method, or what's sometimes called dimensional analysis, is a process that we use to convert between units. In order for this process to work, we must have what are called conversion factors. And a conversion factor is just something equals something else. So for example, we have 1 foot equals 12 inches. That's an example of a conversion factor. 1 day equals 24 hours. Anything like that where you have two things set equal to each other. Now the notation that we're going to use for this is this horizontal line and vertical line. I sometimes call this train tracks. So in our top left box of our train tracks, we're going to put our given. Now the given is going to be the number in the question. This bottom box, most of the time I'll leave it blank, but if you'd like to fill it in, you can put a 1, or it's also used for a denominator unit. So if we were doing something like miles per hour, we would put the hour down here in the bottom. The one directly across from your given is the number from your conversion factor with the same unit as your given. And then this top box is just the other portion of our conversion factor. So let's do some examples. We're going to start out very simple, and then we'll get a little bit tougher as we go. So our first example says, how many inches are in 3 feet? So if we look at our example, we see that we have a given. Our given is, again, the 3 feet right here. And our goal, we always like to figure out our goal as well. Our goal is what we are trying to convert those feet into. Most of the time, that's going to be very close to the question word. So in this case, our goal is going to be inches. So we want to know how many inches are in 3 feet. So let's go ahead and put in our train tracks. So here's our train tracks. Now again, our top left box is for our given. So we'll put the 3 feet down there. Now we need to come up with our conversion factors that we can use. Well, we know from the first slide that 1 foot equals 12 inches. And in this case, that's the only conversion factor that we need to do or need to use to go from feet to inches. Okay, so we'll go ahead and fill in that bottom box with a 1 because we don't have a denominator unit this time. And so now we need to fill in this bottom right box. Okay, this is going to be the unit or the one from the conversion factor with the same unit as your given. So if we look at our conversion factor, the number with the same unit as our given is the 1 foot. So I'm going to put that 1 foot in the bottom, and then I'll finish out the conversion factor on top. Now I have feet on the top and feet on the bottom. Anytime you have the same thing on top and on bottom of a fraction, it cancels out. And so my new unit is inches. To do the math here, all we're going to do is multiply across the top, multiply across the bottom, and then divide. So 3 times 12 is 36. 1 times 1 is 1. And so 36 divided by 1 is going to be 36 inches. Okay, let's take a look at another type of example. This is going to be a metric conversion. So we want to convert 764 nanometers to kilometers. So our given this time is the 764 nanometers. Our goal is to convert that into kilometers. And so I've given you the 2 conversion factors here that you are going to need in order to do that, since you probably don't know those off the top of your head. So here's our train tracks. Again, we always start with that 700 or that given in the top left box, so 764 nanometers. Okay, and so our 2 conversion factors here, we have 1 nanometer equals 1 times 10 to the negative 9th meters, and 1 kilometer equals 1,000 meters. So we need to figure out which one of these 2 conversion factors to use first. But we see that our unit on our given is nanometers. So that means that we want to put nanometers down here on the bottom. And so the number that goes with nanometers is 1. So we'll put the 1 nanometer on the bottom. And then we'll finish that conversion factor out with the 1 times 10 to the negative 9th meters. Since I have nanometers on the top, nanometers on the bottom, those cancel. My new unit is meters. That's not what they asked us for, so I'm going to add another vertical line, and that way we can use another train track. Okay, so our next conversion factor, now we have meters on the top. We don't want to use this one again because we've already used it. So we must be using this one down here. So since I have meters on the top, I want to put meters on the bottom, and the number with meters is 1,000. So I'll put the 1,000 meters on the bottom and the 1 kilometer on the top. My meters cancel out. So my new unit is kilometers. Again, to do the math, you multiply everything across the top, multiply everything across the bottom, and divide. And that's going to come out to be 7.64 times 10 to the negative 10th kilometers. Okay, we have one last example. This is going to be a word problem. These can be a little bit tricky when you're trying to find all the information that you need. So this one says, Martha wanted to buy several boxes of shirts for the men in her family. The shirts were $29 per box, and there were 5 shirts per box. Each shirt sold separately for $6.25. How much would Martha pay for each shirt if she bought them by the box? And then which is the better deal, to buy the shirts individually or to buy them by the box? Okay, so as always, we want to pick out our given and our goal. So when you're looking for your given and your goal, you want to find the question word or the question itself. So our question actually starts right here. How much would Martha pay for each shirt if she bought them by the box? Well, we need to find a number in that question. Well, we don't really see a number, but we do have a word that means a number, and that is each. Each tells us 1. So our given is going to be 1 shirt. Now we need to figure out what is our goal. What are we trying to convert that into? Well, that would be this part right here. How much would Martha pay? So we're looking for money. All right, so now we can start our train track. We have our given. So there's our given of 1 shirt. Now we need some conversion factors to help us. When you're looking at word problems, if you see the word per, or if you see the line that means per, that's a good indication that that's going to be a conversion factor. So in this case, they told us that there's $29 per box and 5 shirts per box. So I can take those and convert them into conversion factors. So we would say $29 equals 1 box and 5 shirts equals 1 box. Okay, so now that we have our conversion factors, we can start filling in our train tracks. Since I have shirt on the top, I want to put shirt on the bottom. The number that goes with that is 5. So for every 5 shirts, that's 1 box. Okay, so now I know how many boxes, but that's not what they asked me for. They want money. So now we're going to use the other conversion factor. I'm going to put the 1 box on the bottom. So it cancels out, and that was equal to $29. So when we multiply across the top, multiply across the bottom, and divide, we see that each shirt is going to be $5.80 when you buy it by the box. So to answer the second part of the question, it is a much better deal to buy them by the box. Now, there are a couple of other conversion factors that you might find useful. When we talk about milliliters, those are the same thing as a cubic centimeter or a cc. Those things are all equal to each other. And later on in the course, you'll have to convert between Celsius and Kelvin temperature. We do have a formula for doing that. You just add 273 to the degree Celsius. This formula is also on your reference table so that you can find that.